want to take a moment and talk about arithmetic sequences, but I want to relate them to something that we've done already, which are the equation of a line. So just to kind of quickly recap, in an arithmetic sequence, we know that the general equation is the first term plus n minus 1 times the common difference, or we could write the first term plus whatever the common difference is times that. So that is kind of the general formula for an arithmetic sequence. Now let's just kind of start with an example. Let's take an easy arithmetic sequence. Let's say we're going to start with 2, and then we go 5, 8, 11, 14, and then we continue that. So that's just a nice easy arithmetic sequence. 2 is my first term. I'm taking a look at it and I realize that each term is being increased by 3. So the common difference is 3. So first term is 2, common difference is 3. Well, I could make an equation for this. The equation for this, using our general formula, would be something like the nth term would be the first term plus the common difference times n minus 1. Okay. If I were to want to maybe graph this on like a coordinate plane, how would I do that? Well, first I would probably need a list of points. And so I'm going to make a kind of an XY table. But first I'm going to say my X terms is going to be my term number. And then my Y coordinates is going to be what my actual number is. Okay. So if I were to label my number of terms, this 2 here, this would be term 1. This would be term 2, term 3, term 4, term 5, and so on and so forth. So let's go back here and fill in my table. My X coordinate, my first term is 2. So I could actually create another, what is going to be my coordinate point. This would be the point 1, 2. And then my second term is 5, and that creates the coordinate point 2, 5. My third term is 8. This is the coordinate point 3, 8. And then so on and so forth. My fourth term is 11, which creates 4, 11. My fifth term is 14, which creates 5, 14. And then I could go ahead and I can graph this. So I'm just going to make a kind of a rough graph right here. Okay, I went ahead and graphed these. My graph isn't exactly precise. It was just a rough estimate, but generally that's what's happening in my graph. And obviously I can continue this line forever in both directions. Now let's just kind of take a point and look at what this line means. If I take a look at my line, I know that for every x, I'm going up by 3. So, and I can take a look, each x value is being increased by a constant amount, by 1. Each y value is being increased by a constant amount, that's 3. And if I were to just kind of take a look at this line and say, can I figure out the slope of this line? I could. So what we can see with our slope is I know that slope of the line is the change in y's over change in x's. So I'm just going to pick 2 points over here to find the slope of my line. And so I do y2 minus y1 over x2 minus x1. And that's 3 over 1, which is 3. Oh, and what do I notice here? 3, well, that's the same thing as my common difference up here with my arithmetic sequence. The common difference was changing by 3. My slope is changing by 3, and that makes sense. Every time a term increases by 1, the term is being added by 3, or is being increased by 3. So that brings us to this point here. The slope is the common difference in an arithmetic sequence. When you have an arithmetic sequence, the common difference of your sequence is the same thing as the slope of the line that you create when you graph that sequence. Now let's take a look, because another thing that when we're looking at lines, we like to take a look at the y-intercept, where it crosses the y-axis. And I know I'm going to be crossing around here. But what does that mean when I cross the y-axis? So my y-intercept, what does that mean? Well, I know at this, I know that x is actually 0. So my y-intercept occurs when my x value is 0, is nothing. Well, I kind of take a look back at my sequence. I start at my first term. I start when x equals 1, not at 0. So what does that mean? What I make an analogy of is, let's pretend my little feet here, my little fingers here are feet, and I'm going to take some steps. And my first step here, my first step is, I take 2 feet, so boop. So that's my first step. My second step, I, take another one, boop, and I keep going. But so that would be my, my first step is my first term. But my 0 term is kind of like where would my position be when, before I ever took a step. So there is something called the 0 term. And that's basically what your y-intercept is. It's your 0 term. So I could go ahead and I could find my 0 term over here, just using what I know. I'm going to go ahead and use y equals mx plus b, right? Slope-intercept form. And I know that my slope is 3 in this case. I want to find what b is. I'm going to take any of these, coordinate points over here. I'll take 1 and 2 because that's nice and easy. My y is 2, my x is 1, still trying to figure out b, and b is going to be -1. So my y-intercept is when x is 0. In this case, it's at -1, which makes sense from my little picture over here. And what does that mean for as far as an arithmetic sequence? My y-intercept is my 0 term. It's my 0 term. So before I would have my term 1, I could technically add a term 0, my starting point, and I would just work backwards. I know that my common difference is I'm adding 3 each time, so I would just take away 3. 2 minus 3 is -1. So my 0 term for this arithmetic sequence would be -1. And that shows up here in my graph of it. That is the y-intercept. That's my y-intercept, is my 0 term. So if I wanted to relate these two kind of equations, so my arithmetic equation that I've been dealing with is, okay, that's my arithmetic equation. And in this particular example, it would be my first term, my common difference, okay? And then if I wanted to relate this to slope-intercept form, which we've used a lot already, y equals mx plus b, where m is my slope of my line, and b is my y-intercept. In this particular case, the equation of the line that we drew up here is y equals, my slope is 3, and my y-intercept was -1. Do you see any correlations between these two equations here? I know that I'm seeing the common difference is the same thing as the slope. So those two things are very easy to see that there's a relationship between. The other thing that's slightly different that some students get confused on is these two things are saying the same thing, but they're using different labels, a different starting point. This equation right here, slope-intercept, the starting point is the y-intercept. We start where this crosses the y-axis, and then we kind of go from there. And that is basically considered the 0 term of the sequence. But here, up in this one, we're starting with our first term in the sequence. So these two things are basically saying the same thing, but they're starting at a different point. Here, we start at the 0 term before I ever take a step. Here, I'm starting at the first term. I've already taken the step, and here I am, and I'm starting from here. But there is a definite connection between arithmetic sequences and the formula that we use for an arithmetic sequence and slope-intercept form, which we've used a lot with linear equations. So I just wanted to show you the connection between arithmetic sequences and linear equations, slope-intercept form.